Here we'll look at a group of trig identities known as the Pythagorean trig identities. The most well-known of these is when you add the squares of the sine and cosine of an angle. We'll also be looking at simplifications for tan squared plus 1 and 1 plus cotangent squared. But first, let's start with a right triangle. Suppose this angle here is theta, and let's call the side lengths A, B, and C. Which of these is the correct relationship between these side lengths? If you're not sure, click over here to review. Exactly. The Pythagorean theorem says that a squared plus b squared equals c squared. Now suppose the hypotenuse of this triangle is 1. In terms of theta, what's the length of this side over here? Right, it's sine theta. And what's the length of this side down here? Right, it's cosine theta. So now try using the Pythagorean theorem to evaluate this expression. The square of sine theta plus the square of cosine theta. Precisely, this sum is equal to 1. Now an equivalent way to write the square of sine theta is like this. It means the same thing. Take the sine of theta and then square it. This is a shorthand way to write that, and you can read it aloud as sine squared theta. And we can do the same thing here with the cosine. So for any value of theta, sine squared theta plus cosine squared theta equals 1. This is our first Pythagorean trig identity. So let's hold on to it up here. Let's find some more identities. First, let's look at what happens if we divide both sides of this equation by cosine squared theta. Let's look at this first term over here, sine squared theta over cosine squared theta. How can we rewrite this fraction? Right, it's tan squared theta. Next, how can we simplify this fraction, cosine squared theta over cosine squared theta? Right, it's 1. And finally, how can we rewrite this third fraction, 1 over cosine squared theta? Right, it's secant squared theta, since secant theta is defined as 1 over cosine theta. So for any angle theta, tan squared theta plus 1 equals secant squared theta. And that's our second Pythagorean trig identity. Let's return to our first one. Sine squared plus cosine squared equals 1. And let's now divide this whole equation by sine squared theta. How can we simplify this first fraction? Exactly, it's 1. And how can you rewrite this next fraction, cosine squared theta over sine squared theta? Nicely done. Cotangent equals cosine over sine. So cosine squared over sine squared equals cotangent squared. And how can we rewrite this last fraction over here, 1 over sine squared? Right, cosecant equals 1 over sine. So this fraction equals cosecant squared theta. And that's our third Pythagorean identity. For any value of theta, 1 plus the cotangent squared of theta equals cosecant squared theta. So these are the 3 Pythagorean trig identities. This first one, sine squared plus cosine squared equals 1, is the one you'll see most often. And by dividing it by sine squared or cosine squared, you can show that these other 2 identities are true as well. Let's see if we can find some trig identities for the sine, cosine, and tangent of half an angle. So we want to write the sine, cosine, and tangent of a divided by 2 in terms of the sine, cosine, and tangent of a. We'll be figuring these out by starting with the double angle identity for the cosine function. Which of these expressions is equal to the cosine of 2b? And if you want to review the double angle identities instead, then click here. Right. Cosine of 2b equals cosine squared b minus sine squared b. Now suppose a equals 2b. So we can plug in a for 2b on the left side. So what does b equal in these 2 terms on the right? So try using this equation to find b in terms of a. Right, so for any angle a, it's true that the cosine of a equals cosine squared a over 2 minus sine squared a over 2. Next, let's try to solve for these trig functions of half angles. To do that, we can use a relation between these 2 terms. What is sine squared of a over 2 plus cosine squared a over 2? If you're not sure and you'd like to review how to evaluate expressions like this, then click here to learn more about Pythagorean trig identities. Exactly, this sum is equal to 1. Let's subtract sine squared a over 2 from both sides. Now we have an expression for cosine squared a over 2, so let's plug it into the equation up here. We're subtracting sine squared a over 2 and then another sine squared a over 2. So that's minus 2 sine squared a over 2. Let's solve for the sine of a over 2. We can do that by first adding 2 sine squared a over 2 to both sides. And then we can subtract cosine a from both sides. Next, let's divide both sides by 2. Remember that sine squared a over 2 means the same thing as the sine of a over 2 squared. So, if we're solving for the sine of a over 2 here, one solution is to take the square root of both sides. So the sine of a over 2 can equal the square root of 1 minus cosine a over 2. But there's a second possible solution here. What can you put in front of the square root to get another solution for sine of a over 2 in this equation up here? Exactly, so the sine of a over 2 can equal the square root of 1 minus cosine a over 2, or the negative square root of 1 minus cosine a over 2. Let's combine these two possibilities into a single equation. So this says that the sine of a over 2 equals plus or minus the square root of 1 minus cosine a over 2. Now this does not mean that the sine of a over 2 can equal two different things. For any given value of a, the sine of a over 2 only equals one number. For some values of a, the sine of a over 2 equals the positive square root, and for other values of a, sine of a over 2 equals the negative square root. So be careful when using this identity. So let's hold on to this identity up here. Next, let's find an identity for the cosine of a over 2. Again, let's start with these two equations. Cosine a equals cosine squared a over 2 minus sine squared a over 2, and sine squared a over 2 plus cosine squared a over 2 equals 1. Last time we subtracted sine squared a over 2 from both sides. This time, let's subtract cosine squared a over 2 from both sides instead. And now we can plug in this expression for sine squared a over 2 in the equation above. Distributing the minus sign into this expression gives us minus 1 and plus cosine squared a over 2. Cosine squared a over 2 plus another cosine squared a over 2 gives us 2 cosine squared a over 2. To solve for the cosine of a over 2, we can add 1 to both sides, and then divide both sides by 2. So which of these is the correct identity for the cosine of a over 2? Right. So the cosine of a over 2 equals plus or minus the square root of 1 plus cosine a over 2. Like the sine of a over 2, cosine of a over 2 equals one number, but for some angles it's a positive root, and for other angles it's the negative root. Finally, let's look at the tangent of a over 2. Tangent equals sine over cosine, so tan a over 2 equals sine a over 2 over cosine a over 2. Let's plug in these identities for the sine of a over 2 and cosine of a over 2. We can combine these square roots into a single square root, and the 2's cancel out. So the tangent of a over 2 equals plus or minus the square root of 1 minus cosine a over 1 plus cosine a. And just like with sine a over 2 and cosine a over 2, the tangent of a over 2 equals one number. For some angles it's the positive root, and for other angles it's the negative root. So here are your half-angle identities.